To warm us up, we're going to try a couple examples before we get into really what this section is going to be assessing you all on. So A says, simplify tangent theta over secant theta by rewriting in terms of sine and cosine. So this is giving us a hint. When we get further in the lesson, we'll have to come up with it on our own. Well, if I want to put it in terms of sine and cosine, the first thing I'm going to do is rewrite the expression. Well, I know, I'm going to switch colors on us so it stands out, that tangent of theta is equal to this piece, right? So I'm going to replace tangent theta with sine divided by cosine. Well, what is secant theta equal to? Going back up to my sheet, looks like this guy. Okay, so I'm going to replace that with 1 over cosine theta. Now I don't really want to leave it like that. So when I'm dividing fractions, I keep the numerator and multiply by the reciprocal of the denominator. And what you'll see here is that these cosine thetas can reduce out. And so we end up getting that this is just equivalent to sine of theta. So really what this is testing, if anything, are your algebra skills. And that is imperative for you to be successful in calculus. It's not calculus that's the challenging part. It's just the algebra that you've learned up until this point that you have to use in calculus. So if you are struggling with these, please reach out to me because it's probably an algebra mistake, if anything, and not a trig mistake. So B. Now we're just like building some techniques, okay, or refreshing our memory of how we deal with certain things. If I'm adding two fractions together, I need to find a common denominator. Well, these denominators don't share anything because they're terms. So my lowest common denominator, if you can remember that term, is actually these two expressions multiplied together. So for example, if I had 1/3 plus 1/4, well, they don't share anything. So really our LCD is 3 times 4, which is 12. And then you would make both your denominators 12. All right, so I'm always going to rewrite what I start with. Okay, now I'm going to multiply each term by whatever else I need. So this one needs the 1 plus sine u. And then this one needs the 1 minus sine u. I'm just going to get rid of that. I'll write that above here. 1 minus sine u. Because then they have, oh, forgive me, look at what I did. This has to be exactly the same, otherwise I'm changing the problem. So remember that this value here does not affect it, neither does this, because you're really multiplying just by 1. And that's really important. I can't change the expression. So when I go ahead and multiply these, I get 1 times 1 plus sine u plus 1 times 1 minus sine u. And the whole purpose of that was to put it over the same denominator. Well, then we can clean it up a little bit, okay? So we have sine u take away sine u, so we don't have that. 1 plus 1 is 2. And then I'm actually going to go ahead and FOIL this thing. So if I do 1 times 1, I get 1. I get, negative sine u. And then I get a positive sine u. And then I get a negative sine u times a positive sine u. So I get a negative sine u squared. Well, these terms would cancel out. So I'm left with 1 minus sine squared of u. Now here's the fancy thing. And it's because, yes, I've had experience with these, so I know what to look for. So right now, it's going to feel uneasy, okay? You just have to embrace that. That's the whole point of learning. So it's going to feel uneasy until you do several of these on your own. Well, I know, just because of experience, I have seen this thing on my cheat sheet. So I'm going to go up here. I'm going to refer to this sheet. And what do you know? There it is, right? It's just in terms of u or not theta, so it doesn't really matter. So then I know I can go ahead and replace that with cosine squared. Well, and you don't have to show this step, but just so I don't lose anyone, 2 times 1 over cosine squared means the same thing. And what is 1 over cosine squared? Hopefully you're feeling a little okay with that, but if not, again in the beginning, you're going to have to refer to this sheet often. Well, it looks like it's going to be secant, this guy. So I'm going to go down here, and I'm going to say, oh, this is 2 secant squared. Oh, I unfortunately did not mean to do that. I just changed our input because I'm so used to thetas, but it should be u. So what you just showed is that this piece is in fact equal to this. So this is yet another identity. There's so many out there. All right, let's do one more and then we'll stop this video and give you some practice. So some of us might have been struggling with factoring. We want to make sure you leave 112 feeling really good about factoring. I'm going to post some of my 95 videos on factoring in our shell so you can watch those in case you're really struggling with factoring. So I'm going to always rewrite what the problem gives me. Okay. So when I look at this piece, this numerator, that's a difference of squares. Okay, so to bring you back to your algebra days, like if I had this, that's a difference of squares. And how that can be factored is 1 minus cosine times 1 plus cosine. And so if you're looking at that and you're like, what did she just do? You're going to want to go into Desire to Learn and look at the difference of squares factoring video. Now, in the denominator, what do they both share? What do they both have in common? Sine of v. Well, sine of v times what will give me sine of v? 1. Plus sine v times what will give me cosine v? Sine v, cosine v. Excuse me. Now, this is what's fun about this. You might fight me on that, but I do think it's fun. I can reduce this. So then I'm left with 1 minus cosine V over sine V. I know, again, because of exposure, this can't go any further. But say you're like, but why? I really want to look at this. If you look at your cheat sheet, 1 minus cosine is not on here. Yeah, cosine squared and sine squared are, but not just cosine. So that's why I know, all right, I'm done. That's all I can do. So once again, what we found was this expression is equal to this expression. So here's yet another identity that you do not have to have memorized. You need to know all the identities we made a list for up here. But again, I'm going to reiterate, you're going to use this list often while doing your homework. All right, next video we'll get into proving these things.